In this lesson, we are going to learn how to write simple lambda expressions. These lambda expressions are introduced in SC8, and as part of this specification request, there are many changes that are done. In this lesson, we are going to look at functional interfaces and simple lambda expressions and one simple method reference. I don't cover these things in detail, but they are sufficient to understand what a lambda expression is, how it is helpful. Okay, let's get started. In this class, I have a simple employee with employee ID, name, salary. This employee class has constructor and getters and toString method. Also, it has a comparator method. We are not going to use that. Then coming to our main class, we are creating 5 employees. Then we have added those 5 employees to a list. It is actually an array list that can hold these employees. So here I am sorting the list using the employee salary comparator, meaning these employees will be sorted by their salary in the ascending order. Then I am printing them. Also, I am creating a new thread and I am providing a simple runnable object and I am starting that thread. Also, I created one timer which will call a action performed method in a action listener every 1000 milliseconds, and I called it start method. Then I am sleeping in this particular thread so that these 2 threads will get a chance to execute. Okay, so here is the salary comparator, which is going to compare 2 employees based on their salary, and here is a simple runnable with a run method that is going to print 0 to 10 or 0 to 9, and the simple action listener that is implementing action listener, and action performed is simply printing the event. So all that I am doing here is comparing employees by salary, printing a simple for loop in a new thread, and calling action performed every 1 second. So to do this, I have to create 3 new classes because everything has to reside in an object in Java, right? It's completely object oriented, and we have to write every function inside a Java. That is prior to Java 8 at least. How can we use lambda expressions so that we don't need to have this much overhead? Let me create a new file, copy, paste, and I'm going to call the new class expressions with lambda. Okay, so all that refactoring did is change this class name. Now to get rid of, okay, so because they are in the same package, I can't have the same definition here as well. So to get rid of this comparator, I can use anonymous class. So instead of creating a new employee salary comparator object, I can create a new anonymous class object. For that, all that I need to do is copy from here, paste it here, and call new or call constructor. That is it. Okay, so by doing this, I got rid of this class altogether. By doing this, we got rid of a class, and instead of that class definition, we are using anonymous class. Let's think it further. So our sort method know that it needs a comparator object, so it always knows that it needs a comparator. So I can say this can be always implied whether it is present here or not. Also, because we are providing employee list, this comparator should be able to compare employees. So this can be reduced from this. And this comparator will always override compare method in order to create an object. So it knows that it need to be public int compare. Okay, because it knows it has to compare employee objects, these are not required. Okay, because all that is required is this simple employee1 employee2 object names and a return statement. We even don't need the class parenthesis. So these all things can be understood. They are all implied, they are supposed to be there whenever we have to provide a comparator object to collection sort method. So what is left? If you see here, we have method arguments employee1 comma employee2, and we have method body. That's it. There is nothing else. Everything else is implied. So let's refactor this code to keep only the parts that are highlighted in blue color and remove everything that is in yellow color. Okay, let's do that. I can remove till here. I just need to keep employee1 employee2, and I need a body of this one, and I can remove class curly braces. It is still complaining, right? So I can't simply keep this thing and say that okay, take this and create. It doesn't know, it is syntactically incorrect. So what I need to do is create, give an arrow here, so that this whole thing, like method input parameters and method body, can be treated as a lambda expression. I'm still getting error. Why? If you see here, this is saying employee1 is already defined in main method. This employee1 is already been used somewhere, so I can't use them here. So instead of employee1, let me call this employee11 employee22, and I will use this here. Okay, let's run this one. We got the same output. The employee objects are sorted by their salary. So good. We lost so much code. We have written this code in a very precise manner. So what we need to understand here, instead of creating a new object, also instead of defining a new class, all that we are providing is the method input arguments and method body separated by arrow symbol. That's it. This is good. Now let's go to this thread. Instead of giving a runnable objects, let's see what we can do. If we go here, as we have previously seen, we know we don't need a class name because it is going to be anonymous class. We don't need implements runnable override run because this is all implied. So all that we need is input parameters. In this case, we don't have any input parameters. Even then, we need these open and close braces, and also we need the method body. So let's copy this and let's provide this here instead of a runnable object. And we have to separate input variables with, okay, let's run it. So it is printing from 0 to 9. So we are good here. Let's go to timer object. So till now we have seen two lambda expressions. One lambda expression is expecting two input arguments and another is expecting none. In case of timer, we are providing a action listener and this action performed method, which is implied because it is action listener, is expecting one parameter. So in this case, let's do the same. We don't need a class name, we don't need this implements action listener because obviously it is action listener. We don't need the method name. All that we need is input parameters and method body. Sorry, I didn't copy. So I will remove this and I will paste, and we have to keep arrow here. Okay, I have to import action event. That's good. Okay, so in this case we can further write it in a concise way, because we know that, okay, anyhow this we don't need, because there is a simple expression. We don't need a method open curly braces and closed curly braces along with this comma. We can write it in a very simple way. Okay, so because there is only one parameter, we know that the thing that comes before arrow is method input variables. So we can remove this closing braces. This is implied. Whenever you use simple e, it is nothing but input parameter e. Yeah, this is as simple as it gets using a lambda expression. We can further simplify it. All that we are doing is providing a input argument or input variable and printing it. We can simply say what we are doing is system out println. This will be expanded to this one actually. So in this case it is called method reference, which is expecting one input parameter, and it is printing that. So that is all we need to do. I'm going to comment one of them. See, we got the same output. So what did we do in this method? We have taken a simple example expressions that are present before SC8, and we have refactored it in such a way so that the code can be written in a very precise and simple to understand way. Okay, so let me compare the code before and code after. Okay, if you see, we can further simplify this one. Actually, let me simplify that. We don't need these open and closed statements. And also we don't need return in this case. This is all we need. Let's run it once to make sure nothing is broken. Yeah, it looks good. What is this? Employee list. So see the code, the new code, it is very precise. We have got rid of all these classes, all these overrides, and in this case code is almost same. I mean, but it is here, it is very much understandable. Here also there is no need of creating a new object. We simply give the logic that we want to do in this thread. Here also no need of creating a new comparator object. Simply give the two objects and how to compare that. So this is the power of lambda expressions. They can be written in place and in a very concise way, and it is also easy to understand. In the previous case, I need to go to printing runnable class and then see what is going to happen there, the code basically. But here I can easily say that in this thread I'm going to print value of I from 0 to 9. In this case, I simply know that this timer has a action event, and I'm going to print that event whenever that action performed method is called. So that is a good way of coding. This is all possible because we are using functional interfaces. So let's go here, let's see what are these comparator. If you see comparator, it is a functional interface. What is functional interface? It is an interface with only one abstract method of its own. So if we see here, it has only one abstract method in compare. All other methods are default methods. So, and coming to runnable, it is also functional interface with only one abstract method. It's same with action listener, even though it is not tagged with the functional interface, it still has only one abstract method, so it is a functional interface. Thank you for watching this video. I hope you understood how to write a simple lambda expression. Thank you.